Imagine you run an e-commerce platform and a massive flash sale launches in exactly 20 minutes. You need to instantly find and list your most affordable products from an inventory of millions. If you use a basic SQL select command to try and grab that inventory, the database will dutifully return exactly what you asked for: millions of raw, unfiltered rows of data. Foundational database commands like select tell the system where to look, but they are entirely blind. They retrieve everything without any contextual rules or boundaries. To actually make sense of that data, you need SQL operators. These are special symbols and keywords used to apply logic, perform calculations, and set strict parameters right inside your query. By applying different categories of operators sequentially, we can carve that massive, unwieldy table down to a handful of targeted, useful items. Without operators, your database is effectively a static filing cabinet. Add them, and it becomes an active analytical engine, capable of finding a needle in a digital haystack. Looking at this dataset diagram, we see two separate columns for base price and discount. To find out what the products actually cost, we use arithmetic operators, like addition, subtraction, multiplication, division, and modulus, to mathematically combine them into a single new calculated value. The advantage here is that these arithmetic calculations execute directly inside the SQL query. You get the exact numbers you need on the fly without permanently altering the underlying data in your tables. Once we have that final price, we apply comparison operators. By setting a strict rule that the final price must be less than or equal to 1,000 rupees, the engine instantly filters out the majority of the rows. Applying that one simple mathematical threshold creates an immediate gain in efficiency. The dataset shrinks from millions of records to a manageable fraction, saving massive amounts of processing power. This combination of arithmetic and comparison operators forms the foundational layer of database querying. It allows you to take a qualitative goal, like finding affordable items, and convert it into a strict quantitative rule the computer can execute. We now have a list of cheap items, but our flash sale requires these products to be from high-quality, premium brands. This logic gate diagram illustrates our next step: logical operators. Keywords like and, or, and not act as the connective tissue that allows us to run multiple independent conditions simultaneously. Here, the dataset passes through an and bottleneck, ensuring only items that are mathematically under 1,000 and categorically tagged premium survive. Compounding these conditions forces the database engine to do the heavy lifting. It handles the complex cross-referencing, so you never have to manually match spreadsheets. You will occasionally encounter edge cases, like only knowing part of a product's name. For text pattern matching, SQL uses the special like operator alongside wildcards, such as the %sign, to find any strings that match that specific fragment. If you need to isolate a specific price range, look at this sliding scale diagram. Instead of stacking multiple comparison operators, like greater than X and less than Y, the special between operator checks whether a value falls within a range cleanly and efficiently. You'll also encounter messy data. By using the is_NULL operator, the engine can quickly detect and discard incomplete records, like products that have blank values in their critical description fields. While arithmetic handles the broad numerical strokes, logical and special operators act as a fine mesh sieve. They give you the flexibility to capture the nuanced realities of real-world data. Often, the information you need doesn't exist in a single location. You might have a perfectly filtered query for current inventory, but you also need to include a separate archive of last year's clearance items. This diagram shows how set operators, specifically union, intersect, and except, solve that problem. Here, a union operator elegantly stacks results from two entirely separate queries into one unified list, automatically dissolving any overlapping duplicate rows in the process. As these queries grow, you have to account for operator precedence. SQL follows strict rules. It processes math before comparisons, and conditions before or conditions. To avoid logical breaks in your query, you must use parentheses to explicitly tell the database which operations to perform first. Understanding precedence and set operators is what allows a query to scale across an entire enterprise without collapsing into logical contradictions. Looking at this side-by-side comparison, the massive block on the left represents the millions of raw rows we started with. On the right, after applying our operators, we are left with exactly 5 distinct, highly targeted products ready for the flash sale. Those 5 rows are the result of one unified statement where arithmetic additions, less than comparisons, and logic between ranges and union merges work together in perfect sequence. To consistently achieve results like this, follow a few core best practices. Always handle missing null values proactively, use between for clean ranges, and always use parentheses in complex statements to control the order of operations. SQL is a language, and its power is directly proportional to the precision of the grammar you use to formulate your request. Database capability requires knowing how to write basic code to access information. Mastery requires using operators to carve actionable truth out of an overwhelming sea of noise.